Hello student, today we are going to learn NCRT example 4.11 which is class 12 physics. Okay, so the problem, first we will see what is given in the problem. Okay, then it is a very long question, then we will see how to solve this problem. The number of turns is 100. So the number of turns is it is going to be the 100 turns. The current flowing in the circuit is going to be 3.2 ampere. The next thing, the radius of the coil is going to be the 10 centimeter. Okay, there are 4 questions asked in this question, particular question. Okay, the first question, it is a coil. Okay, it is a circular coil like this. What is the magnetic field? Okay, at the center of coil, what is the magnetic field? First question. Second question, it is a what is a dipole moment? Okay, the same situation, what is a dipole moment? Okay, now third question, what is the torque? So what is the torque? The question number C, the what is the torque is equal to question mark. Okay, when you are measuring the torque, at the same time the magnetic field is going to be the 2 Tesla. Okay, the coil is rotated from 0 to 90 degree. Okay, so this magnetic field and this magnetic field is totally different. This magnetic field is produced by the coil. Okay, this magnetic field, the applied magnetic field. Okay, so applied magnetic field, the coil, solenoid coil, we are going to rotate inside, the torque is going to create. That torque only is a question mark. Okay, this magnetic field is different than this magnetic field. That idea also you should be have. Okay, the next one. The final question is asked, what is the angular velocity? D question, what is the angular velocity? Okay, so 4 question is asked in this particular question. Okay, first we will see A. A is what is the question is asked in A? Magnetic field. Magnetic field due to the circular coil current carrying conductor. We learned this derivation also. It's mu naught times of I divided by we know this value, it's 2R. Okay, in case it is n number of turns. Okay, it's case in number of turns, you should include as a n. Okay, otherwise you can do mu naught I divided by 2R. Okay, here we are given n number of turns. Okay, so now n is 100, which is given in the question. Mu naught is 4 pi into 10 power minus 7, which is a constant value. I in this question is going to be 3.2. So magnetic field, 2. Okay, radius is given in the question. It is a 10 centimeter. Okay, so 10 centimeter is equal to how many meter? 0.1 meter. So 0.1 or 10 power minus 1 also you can tell. Okay, so when we are converting centimeter to meter, just you should divide by 100. Very simple. Okay, when we are converting from centimeter to meter, just divided by 100. Okay, so radius I'll get 0.1. Now calculation I should do. Okay, see how I am going to calculate. This and this is getting cancelled. So 2. So 0.1 is there, no, numerator 10, denominator 10, just directly you can include with 10 extra. Okay, now you should do the calculation. Okay, so see here, 1 2 3 zeros is there, then 2 into 3.14 into 32. Okay, so overall this calculation I'll get 2 into 10 power minus 3. It is a magnetic field, so it is going to be the Tesla. It's very simple. So first question answer I got, the answer is going to be 2 into 10 power minus 3 Tesla. Okay, I hope you know how to do the calculation. If you have any problem to do the calculation, please send me in a chat box and a message. I'll do this calculation also for another video. Okay, B, magnetic dipole moment. M is equal to magnetic dipole moment IA. Usually we will take it IA. In case number of turns is there, you can take it NIA. Here in this question, we have n number of turns. It's going to be the 100. Okay, so 100. Current is flowing is 3.2 ampere, which is given in the question. Area is going to be pi r square. R is going to be 10 centimeter, 0.1 whole square. Area is going to be pi r square. A is equal to pi r square because it's a circular coil, pi r square. Okay, so now pi value is 3.14. Okay, when we are doing this one, 3.14 into 3.2. Okay, so we'll get the final answer. So 3 into 3 approximately 9. This calculation 3.2 into 3.14 approximately we are going to get as a 10. Okay, so the answer is going to be 10 ampere meter square. Current unit is ampere, area unit is a meter square. Okay, so you may want to have one question. This 0.1 into 0.1 we will get 10 power minus 2. Okay, this is plus 2, that is minus 2 will go off. So 3.2 into 3.14, 3.2 into 3.14, that alone we have this answer approximately, which is going to be the 10. Okay, so this will get, the answer is going to be 10 ampere meter square. Okay, C question. What is a C question? The torque is asked when the coil is rotated from 0 degree to 90 degree. Okay, what is the torque formula? Torque is equal to mb sin theta. It's very simple, mb sin theta. Okay, so now theta is equal to 0 degree to 90 degree. Okay, from minimum to maximum with applied of magnetic field is going to be 2 Tesla, which is given in the question. So torque is equal to, m is a dipole moment, which already we found 10. Okay, magnetic field is going to be 2. Okay, sin 0 degree, sin 0 will be 0. Okay, torque will be minimum at 0 degree. So initially torque I will get as a torque minimum is going to be, initial torque will have 0. Okay, then final torque, then we will take it as a changing torque. Okay, so torque maximum, so torque final is equal to mb sin 90. So we are rotating from 0 to 90 degree. Okay, m is 10, b is 2. Okay, sin 90 is going to be 1. So torque final will get as a 20. Torque we can take it force into displacement, which we can take it Newton meter, or we can take it magnetic dipole moment is a ampere meter square. Magnetic field is a Tesla. Like this also you can give the unit. Unit is compulsory. Okay, definitely you should give the unit. The next one, so torque I got 20 Newton meter. Next they asked what is the angular velocity. This is a very important question. D question is what is the angular speed. Okay, this is a question. How I am going to relate the angular speed? I know torque is equal to mb sin theta. Theta is going to be the maximum. Okay, torque is equal to force into perpendicular distance. Perpendicular distance means its radius, f or mb. Okay, force is equal to mass into acceleration. Mass into acceleration into r is equal to mb. In circular motion, I know A is equal to alpha times of r. In circular motion, I know already it is going to be alpha times of r. So m alpha r into r is equal to mb. Just this I substituted in this equation. Okay, what about next equation? So next equation, m r square alpha, m r square alpha is equal to mb. Now very simple. Okay, m r square is going to be the inertia. So inertia also is given in this question. Inertia also is given. Inertia is going to be 0.1 kg meter square. Okay, inertia which is given in the question. So now what I can do, see here. So I related with the same formula with the inertia. So inertia I got alpha, I have like this, is equal to mb. What about alpha? So alpha I can take it as a d omega by dt is equal to mb. The same formula, alpha is equal to angular velocity divided by time. What about angular velocity? So this equation I am going to make it as a d omega by dt d theta into d theta divided by dt is equal to mb. Why I am changing like this? That's another question I have. Because I want to relate with omega. Omega is equal to angular displacement by time. This we can take it as omega I d omega by dt, because it is they asked omega, just I am relating with the omega. So mb, like this the equation is getting modified. Okay, now still we don't have omega. D omega also is there, omega also is there, we need only omega. So d theta from here to here we can take it. Okay, so I omega d omega mb sin theta we have, mb sin theta, sorry, mb from beginning torque is equal to mb sin theta, 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 mb sin theta. From beginning we have the sin theta. Okay, so I have mb sin theta here. So now see here what I am doing. So this d theta I am taken here left side. Okay, it's going to become here d theta. So now I am integrating. Okay, don't do like that, omega square, don't do like that. Okay, so write like this you can write, because we should integrate. So integrate on both the side. Okay, integrate on both the side. It's very simple explanation. Okay, when we are integrating x dx, x square divided by 2. So same way I is a constant, omega square divided by 2. Okay, now here mb, the rotation will be 0 to 90 degree, 0 to 90 degree. It's given in the question. Okay, when we are doing sin theta integration, we will get as a cos theta minus cos theta. okay, cos theta. The rotation will be 0 degree to 90 degree, very simple. Okay, so this I you can take it here, this 2 you can take it this side. So omega square is equal to 2 times of mb minus cos, it's going to be the it's 90 degree, cos 90 degree minus cos 0 degree, because limit I substituted, integration limit. Okay, so divided by inertia. So because inertia became as a denominator divided by inertia. Okay, what about the next step I can do? Next step also will be very simple. See cos 90, this answer will be 0, cos 90 answer will be 0, minus minus will become 1, cos 0 will be 1. So omega square is equal to 2 mb divided by I. Okay, now we know dipole moment, magnetic dipole moment, before only we found it is going to be the 10. Okay, magnetic dipole moment is 10. Okay, magnetic field, what about the magnetic field for this one? Magnetic field is going to be the 20. Okay, magnetic field is going to be the magnetic field is going to be the 2. Okay, then inertia is given as a 0.1, very simple. So this will be 20, 20 into 2 will be 40. So 40 divided by 0.1. So if you want to reduce 0.1 as the 1, so numerator 10, denominator 10, directly multiplication. So omega square is equal to 400 divided by 1. Okay, so when we are taken root of 400, what will get? So it's very simple. Root of 400 answer we are going to get 20. Okay, the unit of this is radian per second, because theta angular velocity by time period, angular velocity is a radian, time period is a second. Okay, thank you for watching my channel. If you like my channel, please subscribe. Thank you everyone.